It's a rainy day, can't work on antennas. Hi, y'all, from K8BYP in Tennessee with a response to a question that a viewer asked. Viewer's username Franzliszt, something I think it is. He seems like he writes really well for being dead several hundred years. Hi. But he mentioned something in my video about W1AL on grounding insanity, which it is. Pay attention to what W1AL says. I did a little digging, and it looks like he has some significant knowledge, and I'll just leave it at that. But he does know something about grounding. But I've never chased this rabbit hole of the difference between wire and braid. I've never gone down that rabbit hole to the bottom, never had a reason to. Just by accident, the day after this viewer asked this question, I jumped right into this mess. And that is with one of these homemade capacitors. And I did a video on this several months ago about something to tinker with, how to make capacitors with copper discs and plastic. And for convenience, knowing it's not ideal, I used solder wick, the real fine copper braid, because it's easy to solder and flexible, and I can twist it and bang it and drop it and such, and it'll work a long time. Solid wire will try to break off. So just for testing, that's what I used. That is about 25 picofarad there. 2 copper discs about 1.5 inches, 2 thicknesses of about 15 thousandths. I think that's HDPE. Very good dielectric, low loss. But on the high precision Beckman DMM capacitor range, it reads, if I can get it stable with one hand, it reads, come on, 26 picofarad. I don't have a free hand to hold it on. So that's 25 puff. That's just the capacitance I needed. I know that when I put something with that big surface area in a real circuit, there'll be some stray capacitance, but I've got an adjustment in it, air variable. So no problem. So I put this in the circuit, and it doesn't work. Acts like it's not there. So, well, okay, not enough capacitance, so I took one of the dielectric sheets out to double the capacitance. Put it back in the circuit, still didn't work. Knowing I'm wasting my time, I changed the dielectric sheet to what would be about 80 picofarad worth, and it still didn't work, and it did the same thing every time, and it can't do that. I change those dielectric sheet thicknesses, it will change the capacitance, and I can measure it. But the results on the MFJ squawk box were that capacitor wasn't even there regardless of the dielectric, and that cannot be. And the only thing that can be due to is this braid. So what I mentioned to Franzliszt is that this braid is made of very, very fine wires woven together. Those wires might be, I don't know, 45 AWG. They're extremely fine. The wires in an RG58 coax shield might be, I don't know, 35 or 38 gauge, but extremely small diameter. And I explained that there's 2 basic things going on. Each wire length has inductance and resistance and skin resistance. The skin resistance goes up tremendously above a few hundreds or thousands of cycles. Skin resistance is basically RF resistance of a wire. Well, those extremely thin wires have a very high skin resistance and very high loss. Very, very thin wires will have very high inductance. There are a lot of them put in parallel, so that will reduce the inductance by the number in parallel. But overall, this is not suitable for RF. This is probably not suitable for over 100 kilohertz. And that braid, in order to do what it did in this circuit, for this capacitor at 25 picofarad, which is about 300 ohms at 21 megahertz, 300 ohms reactance, For that capacitor to appear open circuit, let's assume that the inductance of both of those braids is like 10 times, or about 3,000 ohms inductive reactance and or including resistive losses. So that braid is such a high impedance that there is not a prayer it's going to be a ground braid at 21 megahertz. It's an open circuit. And the factors, if you want to take a shot at calculating it, it's not terribly hard. But look up the skin resistance formula. There's a wiki on skin resistance. And the formula from Rosa, 1919, for inductance of a round wire, and each of those are round wires, is 0.002 times the length in centimeters, times 4L. I think it's 4L. Times the natural log of the length of the conductor divided by the diameter in centimeters minus 3/4. So length divided by diameter, take the natural log ln, add 3/4, multiply that by 0.002 times the length in centimeters. And that'll give you microhenries. So what you'll find with this, with such extremely small conductors, that braid is a very high impedance, and this test proves it, but I've never been there before, never had a reason to. What might become obvious to you if you've seen more of my videos is that this also proves the myth of putting clamps and ferrites on the outside of a transmission line to stop some mythical currents going down the outside of the shield. I actually found that mythical reference in an old textbook. It's false. That is about 2 inches worth of braid there. How much impedance do you think you're going to have in 100 feet of that? The RG58 outer shield has a lot more conductor area in it, but it's a tremendous amount longer. So for fun, if you got a pair of calipers and a calculator, get some RG58 and measure the shield wires accurately, and take 100 feet, convert that all to centimeters, and figure the inductive reactance and the skin resistance of 100 feet of that transmission line outer conductor. There is no chance that there are going to be these mythical currents going down this shield, and such an extremely high impedance that putting that Mickey Mouse clamp on it will do absolutely nothing. For a very, very short coax jumper, maybe inches or feet, maybe would help a little bit, but it is pure BS. But this will have any effect whatsoever on a 30, 50, 100, 200 foot transmission line going out to an antenna. So here's why. So the fix for this is to simply take the convenient braid off and solder either copper strips or round wire to it. Not difficult, but there, Franzliszt is a more or less proof of the question you're asking. 73 KBYP dit 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 dit.